In this video, I'm going to talk about the basic concepts in number theory. We will prepare you the concepts and techniques which are necessary for Dr. King's lecture. So what are prime numbers? A prime number is a natural number greater than 1 that has no positive factors other than 1 in itself. For example, 98,764,321,261 is a prime number because it has no positive factors other than 1 in itself. On the other hand, 17,848,119,339 is not a prime number because it can be factorized as 3 cubed times 29 times 22,794,533. Greek mathematician Euclid proved that there are infinitely many prime numbers in more than 2,000 years ago. But many mathematicians and computer scientists continue to search for large prime numbers. As of July 2018, the largest known prime number is 2 to the power of 77,232,917 minus 1. This is a number with 23,249,425 digits. So without the use of a calculator or a computer, how can we check whether 8,388,607 is a prime number? So this number can be factorized into 47 times 178,481. This is not easy to do without a calculator or a computer. So we do not know any simple formula that can separate prime numbers from composite numbers. But there are some tests that we can use. One of the tests which has been known for more than 2,000 years is called the sieve of Eratosthenes. First of all, we will remove all the multiples of 2. And then we will remove all the multiples of 3. Then we removed all the multiples of 5. And so on. So the remaining numbers will be the prime numbers. So the prime numbers from 2 to 120 include 2, 3, 5, 7, 11, and so on. Another Primality test is called the trial division. So we want to know whether n is a prime number. Then what we have to do is to check all the prime numbers from 2 to square root of n and see whether they can divide n. If n is divisible by any of these prime numbers, then n is composite. Otherwise, it is primed. For example, if I want to know whether 689 is a prime or not, then I have to check whether the prime numbers from 2 to square root of 689, which is 26, divides 689. So the prime numbers from 2 to 26 include 2, 3, 5, 7, 11, 13, 17, 19, 23. And then I use 689 to divide all these numbers. So if 689 is divisible by any of these numbers, then it is composite. Otherwise, it is primed. It seems like it makes more sense to check from 2 to n-1 rather than from 2 to square root of n. So why do we only check until square root of n? For example, when n is 100, then I know that 100 is 2 times 50, 4 times 25, 5 times 20, 10 times 10. So the factors of 100 include 2, 4, 5, 10, 20, 25, and 50. So if I want to check whether 100 is primed or not, I only need to check the prime numbers from 1 to square root of 100, which is 10. So I only need to check 2, 3, 5, 7. The reason is, whenever I find 2, then I will find 50. Whenever I know 5, then I can find 20. So whenever I find the first half of them, then I can find the remaining. Have you watched the movie The Man Who Knew Infinity? It talks about the relationship between G.H. Hardy and Ramanujan. So the mathematician G.H. Hardy once mentioned in his book a mathematician's apology. I have never done anything useful. No discovery of mine has made, or is likely to make, directly or indirectly, for good or for ill, the least difference to the amenity of the world. So what he means is that what he has done on number theory has no application in this real world. However, this statement is not true. This number is called illegal prime number. So I don't mean this as a number. This is not a prime. I mean the whole thing, all these digits, as one single number. So why is it illegal? What's the application? Illegal prime number is used to protect the contents in DVD. I'm not sure if you have heard about it or have seen a DVD, but it used to store movies. Since people do not want the movies to be copied by different people, basically we are not allowed to copy the contents of the DVDs into a computer or into another storage. So the DVD contents are usually protected by codes. And this code is called illegal prime number. Under the Digital Millennium Copyright Act, we cannot publish the illegal prime number. With that said, you can publish the number into your t-shirt, you can publish it on the internet. But right now it should be fine because no one actually uses DVD right now. So that was something like 20 years ago. So what's the application of prime numbers nowadays? Prime numbers are largely used in information technology, for example, public key cryptography. So basically every time you log in Google, you log in your portal, some people actually use cryptography to protect your data. The principle is easy to understand. So basically, you think that multiplication is easy. No matter how big the numbers are, you can do multiplication. It just takes time, right? But factorization is difficult. Did you remember that? If you need to test whether a number is prime, you actually need to test all the prime numbers from 2 to square root of n, right? So it takes a huge amount of time in doing factorization, especially when the number is very, very large. And that is why prime number is used in public key cryptography. In Dr. King's lecture, he will explain more on public key cryptography. So right now is your exercise time. The video will stop here. Please go to Moodle to work on the exercise related to prime numbers. And then after that, you will start the next video.